Good morning to all. I am Prabha K, working as Assistant Professor in the Department of Electronics and Communication Engineering, Sai Vidya Institute of Technology, Bengaluru. Today we'll discuss about the methods used to access the IO devices. This is the major topic in the Module 3 of Computer Organization and Architecture subject. We know that input and output modules are the major functional units of computer system. How these IO devices have been organized in order to make the computer system to communicate with the external world. The input and output organization of computer depends upon the size of the computer and the peripheral connected to it. The IO subsystem of computer provides an efficient mode of communication between the central system and the outside environment. The basic feature of computer system is its ability to exchange data with other devices. Peripheral devices are external devices which are connected to an IO module to provide a means of exchanging data between the external device environment and the computer system. The most common input and output devices are keyboard, mouse, sensor switch, digital camera, microphone, monitor, printer, magnetic tapes, actuators, speakers. In this, the first keyboard, mouse, sensor switch, digital camera, microphone, all these comes under the input device. Monitor, printer, magnetic tapes, actuators, speakers, fire alarms, they come under the output devices. The IO organization of a computer system is analyzed with the help of the types of external device. External devices are categorized into three types. External device which can be read by the human being, those are called as human readable, which mainly suitable for communicating with computer user, video display terminals, printers, etc. Machine readable external devices suitable for communicating with equipment like magnetic disc and tape systems, sensors and actuators. The communication related external devices are suitable for communicating with remote devices such as a terminal or a machine readable device or any other computer. Input-output interface is required in order to connect an IO device to the computer system. This interface provides a method for transferring information between internal storage like memory and the CPU register and the external devices. These peripheral devices are connected to a computer need a special communication links for interfacing them with the central processing unit. As we know already, the computer system is an integral part of our home appliances, a manufacturing sector, transportation system, banking sector, and also at the point of sale terminals. The input signal may come from any of the input device suitable for that particular application. The output may be a sound signal or a digitally coded command suitable for that particular application. In general, the computer system should the ability to exchange the information with a wide range of devices in varying environment. Now we'll analyze how the IO devices are accessed. Consider a diagram. Here it is very clear that the processor, memory and number of IO devices are connected together with a single bus. The number of IO devices can be designated as IO device 1, IO device 2, IO device 3, like that IO device N. N number of devices can be easily connected to the computer system with a single bus structure. This figure shows a simple arrangement to connect number of IO devices to the computer system. With the help of bus, IO devices are connected to the computer system. This bus enables all the IO devices connected to it in order to exchange the information. This bus usually consists of three sets of lines which carry signals, and these lines are categorized as address lines, data lines and control lines. Each IO device is assigned with a unique set of address. When the processor places an address of a particular IO device on the address line, the device that recognizes this address and then responds to the commands issued by the processor on control lines. The processor requests either a read or write operation, and the requested data are transferred over the data lines. When IO devices and memory share the same address space, the entire arrangement we call it as memory mapped IO structure. With memory mapped IO, any machine instruction that can access the memory can be used to transfer the data to or from an IO device. For example, if data in is the address of the input buffer register, that is data in, associated with the keyboard, then the instruction we can use to transfer the data from the keyboard to the internal register can be move data in R0, where move acts as an opcode. Data in is an address of buffer register related with the or associated with the keyboard, and R0 is the internal register. Data in act as a first operand, R0 act as a second operand. Similarly, the output operation can be analyzed with an example here. If the data out is an address of the output buffer register data out associated with the monitor, then we can use the instruction move R0, data out to transfer the content of R0 to the buffer register of the monitor with the address data out. Move acts as an opcode. R0 is a first operand. Data out is an address of the buffer register, act as a second operand. Most of the computer system uses memory mapped IO system. Some processors have special instructions to transfer the data between IO devices, and these instructions we call it as in and out instructions, which mainly used to perform IO transfer. IO devices uses same address lines which are used by the memory. Only a special signal on the bus indicates that the requested read or write transfer is related to the memory or IO operation. When IO operation signal is asserted, the memory unit ignores the requested transfer and overall operation will be related to the IO devices. The IO devices examine the lower order bits of the address bus to determine whether they should respond or not in order to make sure that the address placed on the address bus is related to the IO device or not. Consider a diagram. Here it is very clear that an IO device, here I have considered an input device, is connected to the bus of a computer system with the help of an IO interface. Here the bus consists of three set of lines: address lines, data lines, control lines. And this IO interface is a module required to connect IO device with the computer system. This figure shows the hardware requirement to connect IO device to the bus. An IO interface mainly consists of three modules: address decoder, data and status register, and control circuit. These three modules constitutes the IO interface circuit. The address decoder enables the device to recognize its address when the address appears on the address lines. Whenever the processor wants to communicate with the IO device, it places the address of IO device on the address line. Address decoder decodes the address. IO device analyzes this address. If it is related to it, it starts responding to the signal sent by the processor. This diagram gives an example of output device connected to the computer system with an IO interface. Here also the IO interface consists of three modules: address decoder, data and status register, and control circuits. The data register holds the data which is being transferred to or from the processor. If it is input device, the data will be transferred from input device to the processor through this data and status register. If it is an output device, the data from the data lines will be transferred to the output device through this data and status register. The status register contains information relevant to the operation of IO device. Whether your IO device is ready or not, a data transfer has to take place or not, all this status information will be provided by the status register. Both the data and status register are connected to the data bus and assigned a unique address. For an input device such as a keyboard, the status register SIN is a part of this interface circuit. So SIN is a single bit status register related to the keyboard will be present in this status register of the IO interface. For an output device such as a monitor, the status register SOUT is the part of interface circuit. Thank you.